Welcome to video 12.2. Today we're going to be talking about creating statistical diagrams. So specifically we're going to first start talking about how to create a box plot. The first thing that you need to do is get the 5-number statistical summary for the diagram using your calculator. And those 5 numbers are your minimum, Q1, median, Q3, and your maximum. So how do we use the calculator to get those 5 numbers? You need to start by going to Stat and then over to Edit like we've done in the past. You will input the data into the list L1. If the data has a frequency list, that needs to go into L2. Then you'll go back to Stat, over to Calculate, and go to 1var stats. In this menu, you need to correctly identify the list used and then hit Calculate. If you have the older calculator, you will see on the home screen 1var stats L1, L2, and we'll talk more about what you need to put in when using a frequency list. Step 2 is making the box plot. So how do we make a box plot? First, you're going to need to write down the 5-number statistical summary and label each piece of information. Then you'll need to have a number line, and you're going to plot those values above the number line. Then the middle 3 plots will be creating the rectangle, which we will separate into 2 smaller rectangles, and then the minimum and maximum are attached to the box so they look like a whisker, so that they have the line just connecting to them. And you must have a title and label so that we know what the information is. So let's start by creating a box plot. So our first example says we need to construct a box plot for the data below that represents the quiz scores in Mr. Stevenson's math class. So what we need to do first is go to Stat, Edit, clear any information that is in your list by hitting Up, Clear, Down. Then we are going to input all of this information in L1 because there is no frequency list. In other words, a list telling us that a given value occurred a certain number of times. Then we need to put all of this data into our L1, carefully double checking and keeping track as you go. Once you've done that, you can go to Stat, Calc, and then select choice 1, 1var stats. Then, depending on your calculator, you may need to tell it that the data is in L1, or just make sure that your calculator says that the data is in L1. Hit enter, and then you will see all of this information come up, which is the mean, and it includes the standard deviation and other things that we'll talk about later. But none of those things are our statistical summary. So you need to scroll down so that you can see n equals 19 at the top. Below that, it should say minimum, Q1, median, Q3, and maximum. That is the 5-number statistical summary which we need to write down so that we can create our box plot. So off to the side, I've written down the minimum, Q1, median, Q3, and maximum. Now I also need to put the data points above those values on my number line. But my number line isn't labeled yet, so we need to start by figuring out what we need to count by. The best way to do that is to figure out how many lines you have and what the range of data is. In my example here, my range I can find by subtracting the maximum and minimum, so 98 minus 52 gives me 46, and then I can divide amongst the 15 line spaces that I have. That tells me, since the answer is 3.06 repeating, I need to count by at least 4, so I'm going to go ahead and count by 5. Once I have that data, I can go ahead and now plot my points above the minimum, Q1, median, Q3, and the maximum. Once you've done your best job with that, now you can go ahead and create the box in the middle. And then we go ahead and put a line through our median, dividing that rectangle into 2 smaller rectangles. And then we can use our minimum and maximum to show that those are the whiskers for that last part. So this goes from here to here, and from our minimum again to the box. And you can put a line here so that you can kind of really see that these are our minimum and our maximum values, and then that is the rectangular part showing where the Q1, median, and Q3 are. Then from here, we still need a title and a label on the bottom. So our label tells us what the data represents, which is quiz scores, and the title is what the whole thing is about, which is Mr. Stevenson's quiz scores. Then from there, we can go ahead and use that box plot to read this information. So this first question here says, what was the median score? Well, I can look in two places. I can look at the list that we created off to the side here where I wrote down what all the important information is, but we can also read it right from the graph by looking. We know that that is this line right here. So the median is 75. That's that middle line. That's what it represents. So that's A. B, is the spread of the data symmetrical or skewed? Well, when we look at this, and it's likely never going to be perfect, but when it's skewed, it means like it's all on one side and there's maybe one piece of information on the other. This, if we look on both sides of the box plot, although this isn't perfectly in the middle, it's pretty even. So I'm going to say that that is symmetrical. The next question, part C, says what percentage of the students scored at or below an 84? Well, where is 84 on our graph? It's here. It's where we plotted the Q3. So when we think about what happens with this data, well, let's go back to median because you've learned about that before. The median is the number in the middle. So that means that 50% are above and 50% are below. Q1, if you remember from the last video, that is our lower quartile, and Q3 is our upper quartile. So that also cuts the data in half. That means that this box plot perfectly separates the data into 25% chunks. This is 25%, this is 25%, this is 25%, and this is 25%. So when it asks us what percentage are at or below an 84, at or below this mark right here would be 25, 25, 25. Add those up, 75%. 75% of the students fell below an 84. And that's again because of what those Q1, median, and Q3 really represent. They are chunking our data into 25% pieces. And I highly suggest that you put those 25% in those showing that they represent 25% of the data. The next question is the range. So again, if you'll recall, what does range mean? Range is like how far our data spreads. So we find that by taking the maximum value and subtracting the minimum value. That'll tell us the range of values. So first I just wrote maximum minus minimum so you know that that's where this is coming from. And then if I look, my maximum data piece was 98 and my minimum was 52, so 98 minus 52 will give me my range value. So that's how you figure that out. And our answer then is 46. So the range is 46. And since I had some work there, I just want to put a box around so you know what the actual answer is. The range is 46. The next question says 25% of the students scored at or below what score? So this goes back to the 25% that we put on our graph here. So which one, we want them at or below what score? So that means that I can't choose up here like this 25% because those would be above. We need below what score? So below would mean this number here or lower. So it's going to be the 68, our Q1 value. And it's important to know if they're talking about below or above. That'll change the value you're looking at. Okay, so for exercise 2 here, it says, which of the following shows a data set with the greatest median? So the key piece of information here is they're asking us to find the median. So that means that I need to look at these graphs and identify where the median is or what the value is. So remember, the median is the middle, that line in the middle of our box in the box plot. So I'm just going to highlight those. So you can see now what we're talking about, but I can't just look at where it's located and identify which one is the greatest. I have to find out what the number it represents is. So if I look at this first one, I have to decide, okay, well, we're going from 20 to 40. So what is this value right here? Well, 20, 25, 30, 35, 40 tells me, okay, this is 30 then, because that's how I went from 20 to 40 based on the tick marks that I have written here. So this value is a 30. So I just wrote it above the median mark so that I know what the median is for this box plot. Now number 2, if I look here, okay, I have to identify what this is. So first I gotta say, okay, what are these counting by? To get from 0 to 50, I think it's 10, 10, 20, 30, 40, 50. So that tells me that this median is 40. In 3, it's 20 here. So to get from 10 to 20, that means that they probably counted by 2. So 10, 12, 14, 16, 18, 20. That looks good. So that means that this value is a 22. So above that, I'll write 22. And then in the last option, if I look from 0 to 5, that means they're counting by ones. So this would be 5, 6, 7. And I'll just make sure 8, 9, 10, that's right. So this value is 7. Now that I have identified what all the medians are, I can answer the question, which one has the greatest median value? Well, if I look at them, that's this graph here, 40 is the highest of all the medians that I wrote down. So choice 2 is my answer, and it's important to realize we had to find the values, because if I just look at which one's the furthest right, it seems like this one must be a really big number because it's all the way over here in the number line, but we have to identify what the value is, because in this one we can see, even though this one looked like it's pretty far left, the number line, the value, showed us that this was actually a higher value. Okay, the next exercise. Okay, so for this one, we have the ages of the 15 employees of the Red Hook Curry House are given below, and we have all this data. We want to create a box plot in the space below. So in order to do this, the steps are we need to import this data into our calculator using the steps that were on the previous page. Okay, so on our calculator, we need to hit the Stat button, and that's right here on the calculator. So Stat. And then once you hit Stat on your calculator, you'll see a menu and it should say Edit, and the first choice is Edit. So you can either hit Enter or the number 1 to say that you want to edit. Then it'll take you to a list. Now, if you have anything in your list, you want to clear it but not delete it. So you're going to hit the up arrow right here, the up arrow. Then you're going to hit the Clear button. And then you're going to hit the down arrow, and that will clear out your list without deleting the list. Then you should have a blank list. If you had anything in L2, you would just need to go over to L2 and then do the same thing. Up arrow, clear, down arrow. Then you'll be able to put all of your data into L1. So you're just going to start by putting in the number 16, so 1, 6, enter. And then in the next one, you'll put 17, so 1, 7, enter. And so on until all of this data that was given to us up here, all the way up to this 44, all of this data needs to be in the calculator. Then you need to go back to the Stat button again. So on our calculator, we're going to go back to Stat. That'll take you back to that edit screen, but you're going to need to hit the over button to go to where you'll see at the top calculate. So it'll be on the top of the screen. I can't show you the screen because this is just a picture I'm using, but on the screen, the second tab will say calculate. And then the first option should say 1 var stats, 1 var stats. So you can either hit 1, or since you're on number 1, you can just hit enter. Now, depending on your calculator, your screen may look a little different once you've gotten to this point. Some will just have that 1 var stats. Others will ask you where the data is. So you just need to tell it that the data is in L1. And to make L1 show up, you're going to hit the second and number 1. See how up in blue on this screen you can see L1 above the 1. So if I hit second and 1, that'll give me L1. If you need to write down that they're in L1, that might not apply. It might already show that it's L1. Then you're going to hit enter, and you should get an X with a bar over it, and then you have all these different pieces of information. We need to scroll down, and the one thing that before we do that, you should see an N equals, that's the number of data entries you have in there, and since there's 15 employees, we should have that number be 15. That's just a way to check to make sure you put in the right amount of data. But if you scroll all the way down, you'll then see the information that we need to create the box plot, the minimum, Q1, median, Q3, and max. Hopefully your screen matches mine. Okay, so this is what I meant by yours should match mine. Your minimum should be 16, Q1 18, median 26, Q3 37, and the maximum is 44. So once we have all those data pieces written down, we're ready to create our box plot, but I need to decide what I want to put on my numbers. So we know that the smallest number we need to show is 16, so I could just start at 14 if we want, and move on from there. You don't have to show the whole thing since this is showing that it goes on forever in each direction. So I'm going to start with the number 14 just so that it's not the very first data point. I have a little bit of space. We could start at 0 if we wanted, but I'm just going to start at 14. And then since I know I need to go up to 44, I can count how many lines we have here, just like we would when we're trying to fit the numbers on a graph. So if we count the number here, and there are 16. So I can start at 14 here and count by twos. That'll get me right to 44 at the end. So that should be fine. It'll spread out our data nicely along the line and just change how the graph looks. If you wanted to start at 0, it would just squish up your graph and it would look a little different than mine, but it wouldn't be wrong. So first, let's go ahead and label those tick marks so that we know what the value of each one is. Okay, so I wrote all my numbers down. Now I'm ready to plot my points, and it depends on what you want to do. Some people put dots at all of these points. Other people put lines at these points. Either way is okay, knowing that eventually we're going to show a line to represent them. So I'm just going to put a line at each of these places, 16, 18, 26, 37, and 44. So the one thing that's important is just knowing that it's in the space above the number line, not on the number line, so I can see it nicely like we did in the previous. And then this is a good setup. Now I have all of my pieces. Now I can create my box by boxing in the middle 3. So this is what I mean by boxing them in. So we start at where this point is, and then we connect those middle 3. So this shows the middle part of our 50% of our data. Then we just show the line going from here to here and here to here. Okay, so hopefully your graph looks like mine. So we have our box plot all set. The next thing that we have to do is label this, and that's helpful because it tells us exactly what this is standing for and helps us to answer follow-up questions. So I was generic with my label here. I just said employee ages. If you want to be more specific, you could say Red Hook Curry House employees' ages, but I just wrote employee ages and then ages in years. So now I know what these things are representing. A says, what is the median age of the employees? Well, median, we can look over in our information that we took from our calculator or read it off the graph, but our median age here is 26. The next one says, the owner is giving a pay raise to the employees with ages in the lower quartile. What are the ages of the employees that receive the pay raise? So if we look, where is the lower quartile? So the lowest 25%. So that's over here. So the age would be between 16 and 18. So between 16 and 18. And then the next one, how many employees are in the top 25%? So I'm going to just put those 25% in there again so you remember where all the data is and how it's broken up. Okay, so now that I put those 25% in there, it might be a little easier to see. We're looking for the top 25%. So top 25% are like our highest 25%, so that would be over here, and it would be the range between 37 and 44. Okay, so since I have a list of data, now I can just look through my list of data up here, which is already in order for us too. Then I can say, okay, well, how many actually fall between that 37 and 44? So when I look up here, there's 1, 2, 3, 4. So then I can see that I just wrote down, the age range, and then there were 4 employees. That's my answer. Okay, now we have this outlier. So what is the definition of an outlier? So this is a data value that is different from all the other values, causing the data to be skewed. So one piece of data kind of screws up the rest of it. It's not in line with everybody else. It's an outcast. It's outside of the other data points. So exercise 4 says that we have a survey was taken amongst 12 people on the number of passwords they currently have to remember, with the results shown in the table. Find the median number of passwords and the mean number of passwords to the nearest tenth. Which better represents the group? Okay, so to do this, we're going to go back to the calculator. We're going to go to those same buttons so that we can put in the number of passwords. Now, this is not a frequency list. This is just saying, okay, the first person has this many, the second person has this many. But this is not like a frequency. One doesn't show up one time. So this is really just, this is the data we want to enter in our calculator to find out the mean and the median. Okay, so hopefully you can follow along with the buttons. Again, it's not going to show on the screen, but at least I can show you the buttons that we're pressing. So we're going to go back to stat. We're going to hit edit, which is the first menu we see there, and then we're going to put in our data. But before we got to clear out anything that might be in there. So to clear it out, hit the up arrow, the clear button, and then down. And if you have anything in L2, which we shouldn't at this point, you would just go over and do the same thing to clear out any list that you have. Okay, then we're going to fill in all of this data. So 1, 2, 0, all the way up to 2. So take a minute, plug in that data so you can make sure you get the same values that I have. Okay, so once you put all the data in, you're going to go back to Stat and then over to the tab on the top that says Calculate. And then again, your screen might look different depending on which calculator you're using, but it should tell you you're doing the 1var statistics to calculate it. When you hit enter to calculate your 1var statistics, you should see X with a bar at the top. And that represents the mean. So that's one of the things that the question talked about. The other one is median. So you see both of those in your list, but the mean is at the top, and you have to scroll down and that to find the median, which is MED in your calculator. Those are the two pieces of data we need to write down so we can compare and talk about them. Okay, so you should have gotten 2.83 repeating for X bar and median 2 from our calculator. That's what we saw in the calculator screen. Now, the instructions that we needed to find them to the nearest tenth. So 2, if we wanted to put 2.0, that would be tenths. We can leave it as 2. But this one we have to round, so the 8 and then the 3 tells us to leave it. So X bar would be 2.8. So the mean is 2 and 8 tenths, and the median is 2 and 0 tenths. Which one is a better representation, better represents the group? Well, since we have one piece of data over here, the 13, that's an outlier. That one is different from all the others. It's much higher than any of the other numbers that we have on our list. So this data piece, if we think about an extreme situation where let's say that everybody takes a quiz and everyone who takes it gets 100, but one person doesn't take the quiz, say they don't make it up, so they have a 0. That 0 is going to make it look like the average is brought down. But really, if we look at the median, most people got 100, but when I find the mean, it's dragged down by that 0. So in this case, this 13 is bringing up our average. It's making our average higher than what the majority of the data actually shows. So the median is the better representation of the data. Okay, so this is maybe a little wordy, but the median is a better representation of the group because it is closer to the majority. The outlier of 13 is bringing the average up. So when we recall, when the data is skewed, then only the median value should be used to describe or represent the majority of the group. Okay, the next one says, students in Mr. Jones' algebra class were trying to determine if people speed along a certain section of roadway. They collected speeds of 20 vehicles as displayed in the table below. Find the mean and median for this data set. So in order to do that, we're going to need to use our one variable statistics. But this time we do have a frequency list. This speed happened for one car. This speed happened for 2 cars. So this one we're going to put the speed in L1, the number of cars in L2, because this is a frequency list. So go ahead and press those same buttons in the calculator. So we start with stat and then edit, so either hit enter or the number 1, up, clear, down to clear out our list, and then we need to put all of these speeds in L1 and all of the number of cars in L2. So pause the video to give that a try. Now, once you have all the data in, the one thing that's going to be a little bit different depending on your calculator is that we have the frequency list this time. So under the new calculators, when you look at that screen, when you go to calculate the 1var statistics, it should come up asking you where your frequency list is. You want to make sure that you're able to say that your frequency list in L2. So you're going to hit that second L2 if it doesn't show up already, showing that in L2 we have a frequency list and all of our data is in L1. When you press those buttons in that way, that should give you the correct mean and median that matches mine. So if you have the older calculator, you have to say L1 by hitting second 1 then the comma button, which is above the 7 right here, then second L2. And that's to tell the calculator that your frequency list is in L2. So that's different depending on whichever calculator you are using. Okay, then your answers should be that the X bar is 36.1, that's the mean, and that the median is 35. The next question says the speed limit along this part of the highway is 35 miles per hour. Based on your results from part A, is it fair to make the conclusion that the average driver does speed on this roadway? So when we see that word average, you're automatically probably thinking, okay, that's the mean. But remember that we need to pay attention to if there's an outlier or not, because when there's an outlier, the mean is not a good representation because it is brought either up or down depending on where the outlier is. So in this case, we have one person who's going 54 miles per hour. So that one person is bringing our mean up because that 54 is bringing the average up. So we would actually want to use the median. It's a better representation of the majority. So most of the drivers, that's what the average driver is talking about. So most of the drivers are actually around 35 based on our data. So I just wrote out that no, we cannot conclude that the average driver speeds because the outlier 54 is making the mean higher and the median is a better representation of the majority. This is because the data is skewed. When conducting a statistical study, it is not always possible to obtain information about every person or situation to which the study applies. Unlike a census in which every person is counted, some studies use only a sample or portion of the items being investigated. Whenever a sample is taken, it is vital that it be fair. In other words, the sample reflects the overall population. We don't want this to be biased in any way. So we have Trong is trying to determine the average height of high school male students. Because he is on the basketball team, he uses the heights of the 14 players on the team. Would the data he gets be a fair sample to use to determine the average height of a high school male student and explain your reasoning? So think about that, and what do you think? Is that going to be a good representation? So my answer was that the data would not be a fair sample because the heights of basketball players are usually higher than the average student, as basketball players are often tall. The next question, to determine which television programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? Give this one a try. So next to these, I just said, if we're talking about a baseball stadium, they probably like sports. You're going to have a lot of people that like sports. A concert hall, people will like music. A comedy club, people like comedy. But a grocery store, since everyone needs food, that's going to be the most random sample that we can choose out of those four. Okay, sorry, this video had a lot of information in it. Hopefully it helps. Have a good night.